Now today we will discuss the bivariate random variable.
Sir,
చెప్పమ్మా.
థర్డ్ యూనిట్ 3.31 and 3.32 ఎక్స్ప్లెయిన్ చేస్తాను.
అది చూస్తానమ్మా, నెక్స్ట్ క్లాస్ లో చేస్తాను, ఎందుకంటే నాకు బోర్డు లేదు. రేపు దాని గురించి
అందరూ అక్కడ స్టక్ అయిపోయి ఉన్నారు. థర్డ్ యూనిట్
అదే అదొక టాపికే కదా. నేను బోర్డు లేదు, బోర్డు లేకుండా మీకు ఇంకా కష్టమవుతుంది.
ఓకే సార్.
స్క్రీన్ విజిబుల్? స్క్రీన్ కనపడుతుందండి?
సార్
ఎవరంటే ఓకే ఓకే. నౌ హియర్ బ్లాక్ 3 ఏంటిది మీకు? బ్లాక్ 3 ఈజీగా స్కోర్ చేయొచ్చా? బ్లాక్ ఇది స్కోర్ చేయొచ్చు. వద్దులే, జాయింట్ కంప్లీట్ అయిన తర్వాత అక్కడికి వెళ్తే బెటర్. Expectation, addition of the multiple theorem and central moment theorem. Okay. Okay, and today we will discuss that is a block 3. It is a bivariate random variable. It is a bivariate distribution and properties and joint marginal and conditional distributions and independence of a random variable. These 3 topics we have to be discussed. In that today we will complete that is a unit 4. We will try to complete that unit 4. Distribution of bivariate distributions law. We can learn that it is a bivariated distributions. Means it is a x is related to y, corresponding the probability is how much. Previously it is we discussed the single random variable. Single random variable means at the time it is a variable x, p of x equal to x. Then what is the probability? Just that we have in the previously. Now I'm going to discuss about that is a joint probability mass function, and the joint means it is a x and corresponding y. That respect to probability. Previously only single variable, that probability we were discussed in the previously. So it is a joint probability mass function. What it will say that it is a x comma y are the 2 discrete random variable, and x and y both are involved at the time corresponding probabilities are defined p of xi comma yj. P of xi comma yj. That representation is called as a joint probability. That representation p of xi comma yj is called as a probability when it is a variable is involved xi, x1 and yj. It means y1. So x1 y1 corresponding that p11. So similarly here x1 y2 means it is a p12. x1 and yj, it is a x1j, x1 and ym, it is a xp1m. These are the representation. I want the total probability of x1 random variable with the corresponding varies of yj. It means that is a p11 plus p12 plus p1j plus so on p1m. It is equal to how much? P1. The total row probability is a p1. Corresponding x2, if I take the row probability is a p2. And xi, if I take that row probability is a pi, and xm, if I take the row probability is a pm. Corresponding y, it is a y1 if I take, and x1, x2, so on xm. that variables are the changes. At the time, that corresponding probability is a P1. So y is fixed and x is changes. So similarly, it is a y2 and corresponding xi, its corresponding probabilities comes to the total probability is a P2. Similarly, it is a column wise probabilities are P1, P2, P3, so on. It means that is a y probabilities. And x probabilities means it is a x corresponding rows total probability. Now I want to go ahead for that is a joint probability density function for two random variables x and y are involved. That comes to the continuous distribution. Whenever it comes to the discrete distribution, we apply that is this kind of the p of xi, x equal to xi comma y equal to yj. So here similarly, whenever I want to go for that is a discrete, this is a probability mass function means it is a discrete random variable. Joint probability mass function means it's a discrete random variable. Whenever I want to go for that is it is a joint probability density function of random variable. X and y is given by f of x comma y equal to 3 by 2 y square. 0 less than or equal to x less than or equal to 2. So 0 less than or equal to y less than or equal. This is a continuous random variable. And it is involving that is a two variables. Now find the marginal conditional density function of x comma y. Check whether it is a x and y is independent or not. So now I'm going to check the marginal density function. What happens? It's a marginal density function. I can find out f of x. F of x equal to how much integral? Interval is a y interval we should take because of I'm taking the function of x. So interval it is a 3 by 2 y square. So that y interval if I take 0 less than or equal to y less than or equal to 1. So it is f of x equal to integral 0 to 1 f of x comma y dy. That is called as a marginal probability density function. Then its corresponding y square integration is a y cube by 3 by 2 constant take common and apply the interval lower interval 0 upper interval 1. So here upper interval substitution 1 cube by 3 minus lower interval substitution 0 cube by 3. So here 1 by 3 into 3 by 2. So that it is a 3 cancels. So that it is 1 by 2 only. Now it is a marginal density function of the y. F of y if I take that is the integral 0 to x interval. And function is a 3 by 2 y square, same function. Here no x terms. So that 3 by 2 y square take the common. And one constant integration with respect to dx is a x. And the interval will take 0 to 2. So that it is a 3y square by 3y square and 2. 2 is there. So denominator 2 is cancelled. 3 by 2 and 2 is cancelled. So 2 minus 0 is the upper interval minus lower interval. And denominator 2 will be there. So 2 minus 0, 2 in the numerator and denominator 2 cancel. So we get only 3y square. Now it is a conditional density function. Conditional density function means it is a f of x by y or f of y by x. It is a conditional density function of x means x in the numerator x by y. So that f of x comma y by f of y. So that is the f of x comma y already he gave in the function 3 by 2 y square. By here f of y just now we calculated 3y square. Just the division it is comes to the 1 by 2. Now, it is a conditional density function of y I am going to calculate. So, f of y by x equal to f of x comma y by f of x. So, here f of x comma y is a given function. Given function is a 3 by 2 y square. F of x equal to how much? 1 by 2. So, previously we calculated in the top. So, here 1 by 2. 1 by 2, 2 is cancelled. So, 3y square. Now, is the both are the same? No. Is the both are the same? Yes. It is both are the same. Therefore, if we both the product is the same, then we can say that f of x comma y equal to f of x into f of y, then both are the independent. So independent conditions means we should check that f of x comma y is a 3 by 2 y square. Here f of x is how much? 1 by 2. F of x equal to how much? 1 by 2. And f of y equal to 3y square. So 1 by 2 into 3y square is a 3 by 2 y square. Both are the same. Therefore, x comma y are independent. That easily we can be identified. The joint probability density function of here random variable x and y. Hello, ma. Example 1 is important. Amma, everyone understood or not? Example 1 is the most important. Hello? Amma, understood or not? Once respond.
Yes.
Hello?
Yes.
Okay, fine. Now I am going for that is a second example. It is a probability density function. Same way I will calculate f of x, integral 0 to 2 f of x comma y dx. Similarly, we can go for the same procedure. Next, giant density function, or giant distribution function of the mass probability mass function. If I take, it is a giant probability distribution function, means it is a cumulative. So capital F of x comma y equal to P of capital X is less than or equal to X, and capital Y is less than or equal to Y. It means that is a discrete. I am coming to the discrete. Previously, I explained that is a continuous. So here, properties of the joint distribution function. If A1, A2, B1, B and B2 are the any two real numbers, then P of A1 less than or equal to capital X is less than or equal to B1, and A2 less than or equal to capital Y is less than or equal to P2. So capital F of here A1, here last one is a B1, B2 plus A1, A2 minus first to last two variables and first two variables. And whenever it is having a mutual adjustment and first and last, last and first, at the time it will go for the negative. This is the properties of the joint distribution function. Always of giant probability distributions, it is a probability capital F of minus infinity to plus infinity equal to how much, means it is a 0. Capital F of minus infinity to plus infinity equal to 1. And capital F of minus infinity comma y equal to how much, it is a 0. And capital F of x comma infinity equal to 0. So if F of x comma y is a joint probability distribution function of capital X comma y, then it is also the F of x comma y equal to dou square F by dou x to dou y. That is also the properties of the joint probability distribution function. See here, small f of x comma y is the probability density function. Probability distribution function is a capital F. So that capital F, say 2 times derivative with respect to x and y, if I do, then it comes to the probability density function. This is one of the property. Now, these are the joint probability distributions. Marginal conditional probabilities. This is a unit 4 over. Now I'm coming to the unit 5. It is a joint and marginal and conditional distribution. Joint, marginal and conditional distribution. Joint, marginal and conditional distribution for discrete random variable, and joint marginal conditional distributions for continuous random variable. 2 cases we will discuss here. In these 2 cases, joint probability mass function is clearly, this is the most important conditions. It is always probability lies between 0 and 1. It means that is every probability is more than 0 and it lies into the 1 less than 1. So that it is any P of x comma y is clearly greater than or equal to 0. And it always total probability is how much along the x-axis, along the y-axis. It must be the 1 only. So summation of the P of x comma y is equal to the 1. This is called as a P of x comma y is called as joint probability mass function of random variable x comma y. Here all the variables, it is a x means summation x means it takes it as x1, x2, so on, xn. And yn means it is a y1, y2, so on, yn, like that. It is a marginal probability function of x comma y. It takes that is a let f of x comma y. If it is take, what happens? It's a marginal means individually I want. That is means it is a P of x1 I want. P of x1 means it's corresponding y changes, but it is x is fixed. X is fixed. So I want to find out that is a xi. Xi means it is a previously we saw in the table. X1 is a fixed and corresponding y1s are changes. So that corresponding row total is called as a P1. That P1 is called as a here P of xi. P of xi. That's all. Xi is the fixed. Instead of x1, I am taking the xi. So x1 and y's are the changes. So here y1, see here first part is a P of x equal to x1 comma y equal to y1 plus P of x equal to x1 comma y equal to y2. So plus so on, plus P of x equal to x1 comma y equal to ym. So here y are changes and x is the fixed. So this is called as a marginal probability function of x. Marginal probability function of x. It is denoted by P of x. And corresponding that marginal probability function of y I want. So P of yi equal to P of y equal to yj. So that P of capital X equal to x1, y equal to yj, and yj, and it means that y is a fixed. At the time corresponding x's are the changes. So here x1. So here you check that P of x equal to x1 comma y equal to yj. Yj is a fixing, and second plus P of x equal to x2, y equal to yj, and plus so on, plus P of x equal to x and y equal to yj. So sum of all probabilities, it is equal to the pj. This is called as a marginal probability function of x comma y. This is a discussion for the random, discrete random variables. Now here continuous means whenever it comes, again it will continue whenever it will come. It means that integrations. That is, you should remember. Now it is a marginal probabilities or probability discrete. It comes always addition. That is, you should be remembered. Next, conditional probability function of x comma y. Conditional probability function, it is a previously marginal. Now it is a conditional in the discrete. So what happened? It is a p of x comma y, x by y is equal to p of x equal to x by y equal to y. So that it is a p of x comma y divided by p of, it is a particular which variable you want. So that y equal to yj. So denominators of x by y means it is a denominator y will be there. So that it is here also denominator you should take y equal to yj. Next, coming to the p of y by x is there. It is a p of x, y by x means it is a denominator. You take x equal to xi, p of x equal to xi. Numerator part is the same. It is a y equal to yj comma x equal to xi. So that it is a numerator part is the same, but denominator part is a, it is a denominator x by y means it is a y is a conditional. So that yj we use, and x is a conditional, the denominator y by x, so that x is a conditional, x is denominator we should take. This is called as a conditional probability function of x and y. Now coming to the continuous distributions, I am going. Continuous distributions, it is a previously here discrete, what happens? It is the p of x comma y is greater than or equal to 0, and total probability is how much? 1. Similarly, here also, continuous also, a function is always greater than or equal to 0, never become the 0, or never become the less than 0. It means that maybe that it is equal to 0, so that greater than or equal to, also I am using f of x comma y is greater than or equal to 0, and double integral f of x comma y dx dy equal to 1. Double integral and along the x and along the y, and f of x comma y equal to 1. This is called as a joint probability density function. Marginal probability density function of x and y is f of x equal to integral y f of x comma y dy, and f of y equal to integral x into f of x comma y dx. So that it is a f of x comma y with the two continuous random variables with the joint probability density function. So joint probability density function means it is a continuous only. So that it is a two variables are there. So that is a marginal probability density function we called, and of x and y. X of x means it is f of x I calculate. Marginal probability density function of x means f of x I calculate, and marginal probability density function of y means it is a, I will use the f of y. F of y, f of x formula is how much? Integral of y interval you should take, and the f of x comma y dy. And the f of y means it is integral x f of x comma y dx. This is a the overall idea about that. It is a, what is the marginal? It is a conditional means f of x by y, same formula, but it is a function I will use f of x comma y. In the first previous unit, what we discussed, it is a there it is a directly we have the functional values. Example one I explained, no? So that f of x by y equal to what is that? F of x comma y by f of y. Same formula we can be used it here. So f of y by x equal to f of x comma y by f of x. This is called as a conditional probability density function of x and y. Conditional probability density function of x comma y. Here, there we calculated f of y and f of x. Here also we can be calculate continuous probability density function of x and y is the same. Next, joint marginal and conditional distribution function. So capital F of x comma y equal to p of capital X is less than or equal to x, and capital Y is less than or equal to y. And marginal distribution function of x and y is denoted by f of x and f of y, and is defined as f of x equal to p of capital X is less than or equal to x. So it is a p of capital X is less than or equal to x comma y, capital Y is less than infinite, and f of y equal to p of capital Y is less than or equal to y, and p of capital Y is less than or equal to y, and capital X is less than infinite. So this is a margin. These all are the joint marginal and conditional distribution functions. But distribution functions we can calculate capital F of x comma y. So capital F of x comma y equal to p of, it is a discrete means p of capital X is less than or equal to x, capital Y is less than or equal to y. And whenever it comes to the marginal distribution function of the discrete, at the time f of x is equal to p of capital X is less than or equal to x. So p of capital X is less than or equal to x. Why we don't know? So that up to infinite we can take less than infinite. And similarly, it is the f of y. Whenever you calculating p of capital Y is less than or equal to y, and p of capital Y is less than or equal to y, and capital X is less than infinite. So this is a overall idea about it. Next, it is a conditional distributions of the function x and y denoted by that function of f of x comma y defined, denoted f of x by y and y by x. So that, and they are given by f of x comma y equal to P of capital X is less than or equal to X by capital Y is equal to Y. So that it is a F of capital Y by X equal to P of capital Y is less than or equal to Y by capital X. These are the terminologies and functions. And here I go for the one example. Once again, all of you review this one once. So once again, all of you check this one, all the formulas, because we are going for the problem. Now here, the joint points of the random variables, he has given the problem. P of x comma 0, 0 is equal to how much? 2 by 9. Here you construct the table. Table once you see, x is 0 and y equal to 0. What is the 2 by 9? And P of x 0 comma 1. From the 0 to 1, y, what is the value? It is 1 by 9. 0 to 1, it is 1 by 9. Next, it is a 1 comma 0 also 1 by 9. So I'm taking the 1 comma 0 also 1 by 9. And 1 comma 1 also 5 by 9. Now, total probability is I'm calculating P of x equal to how much? 3 by 9. Zeros only, it is a y changes and x is a fixed. So P of x is a 3 by 9 and a P of 1 is a how much? 6 by 9 because of it is a 1 is a fixed and 0 and y 2 cases I have to be added. So 1 by 9 plus 5 by 9 equal to 6 by 9. Then we get that is a P of y. My voice is audible? Hello?
Yes, sir.
Now, it is the P of x is how much? It is at the time of the 0. I'm getting that is a total is a 3 by 9. 1 is how much? 6 by 9. And P of y is a total. It is a P of x total is also 1. So corresponding y's and corresponding x's we can calculate. Now it is a whenever I want that. Same similarly, it is a previously what we discussed the problem. Same way here. P of x equal to 0, P of y equal to 1, and P of x equal to 0 and P of y equal to 1. Both we have. Now I will calculate that P of x y, P of y. So that P of x equal to x and y equal to y. It is a P of x equal to x comma y equal to y, and not it is a capital X minus x. That is capital X equal to small x, comma capital Y equal to small y. So that it is a formula as per the formula P of x equal to 0 and y equal to 0. I'm changing that is x and y. So that P of x equal to 0, y equal to 0. Denominator P of y equal to 0. So 2 by 9 divided by 3 by 9. So what is the answer? 2 by 3. P of x equal to 0 and P of y equal to 1. So that P of x equal to 0, y equal to 1. P of y equal to 1. 1 by 9 by 6 by 9. What happened? It is 1 by 9. Now coming to the P of x equal to 1 and
Excuse me, sir, your voice
y
is
equal
too much
to
little.
1. It is a P of X equal to 1 and Y equal to 1. P are divided by P of Y equal to 1. So that it is a 5 by 6. So, similarly, here I can calculate P of Y by X. Here, 4K. Okay.